our session. As mentioned earlier, Tern Poh will be leading us to build a simple AI model to predict student grades. For this hands-on session, we would need you to get online to our website. So please click on the link in the chat box and Tern Poh will lead you through the process. If you encounter issues, please use the chat function for communication and the team will try our best to address them. Tern Poh, please.
Okay, thanks. What we're going to do now is to build a very simple AI model that can predict the grade of a student from their activity on their online e-learning. And on this, before I start, I just want to emphasize a few things, right? First is that after this session, you will not become an AI engineer. And the purpose of this session is to show you give you an appreciation of what goes behind the scene in building an AI model and what are the little things that AI engineers will consider when we build AI model. And I try to bring in everything that I covered earlier in the theory. I bring them to life to show you how they are applied to build an AI model. Okay, so I will be doing a slow hands-on walkthrough, but do not worry if you are not able to catch up or follow the steps, because all the steps that I'm going to do now, they are all in the slides that I'll be shared with you. And I think there's also a video recording, right? So don't worry if you miss out any steps. I want you to focus your attention on the explanations and the concepts. These two are more important because if you have any questions later on, I'll be able to help clarify. So the important thing is understand the concepts, the rationale, and the reasons why certain steps are done, instead of trying to follow through and memorize the steps, right? The steps process can be done later on at your own free time. But the concepts, explanations, don't send email to me once I'm done my lecture now. That's just kidding, right? You can send me questions after this, but just try to follow the concepts first, okay? So to start, right, first you have to go to MS Azure Studio Classic, the website that has been shared with you earlier in the chat, right? So if you go to the site, right, you will come to this page, right? So let me sign out first. I think just now I signed already. Let me sign out of the thing, then I'll re-enter so you can see the same screen of what I'm seeing earlier. Hang on. So let me go to that again. So it's MS Azure Studio Classic. Yeah, so you should see that if you click on the link on the chat, you should come to this page, right? Exactly this page, right? So I will need you to sign in. You can use any Hotmail, Outlook email that you have, or any Microsoft account that you have. It is free. You don't need to use any, and don't need to enter any credit card information, etc. Okay, so I just pause here for a short, maybe like 20 seconds for everybody to sign in into whatever account that you have with Microsoft, be it Hotmail, Outlook. Just give it a try. I believe most of you should have it. For those who don't have any existing Outlook account, don't worry. You can just follow through first. And again, the purpose of this session is not to train you to become an AI engineer, but to explain to you the concepts behind the theory that I gone through earlier, and I bring the concepts to life. Okay, so in fact, I will, for those who prefer, in fact, I would rather prefer you to listen to my explanation than do the hands-on step-by-steps, so that you can like truly grasp the concepts. Then later on, after this, you can rewatch the slides or the videos to follow through. Okay, so once you have signed in, right, you should see this screen here. This screen, yours will be empty because I have done a lot of other training sessions and do some modeling myself here. So you see a lot of experiments here, but yours will be empty. So to get started, right, what you can do is that just go to the left-hand side of the screen. You can see this thing called the experiment on the left-hand side here. So go ahead and click on the experiment. You should come to this page here. Okay, once you come to this page, right, you go to the bottom left, you click on new, okay, and a blank experiment. Okay, so you should come to this page here. So I'll just do a quick run through with you on this interface, right, to get familiarized with it. So again, right, don't worry if you can't follow through. Focus on the concepts, right? The instructions to follow on the steps are on the slides, right? So here is the canvas, the main part of the workspace, right? You can just drag and drop any functions or boxes to here to run the experiments. Okay, so over here on the left is all the list of features that you can use to build an AI model. So the good thing about this platform is that, right, there's no code involved, zero code. So you can just drag and drop to build an AI model. Okay, so before we start, right, first thing we have to do is to upload a data sets. So if you go back to new again at the bottom left, right, you click new, you click data sets, right, here, you have to upload a data set which we're going to use to build an AI model. And the data set will come from the link that I share in the chat, the Excel sheet, right? So after you have unzipped the Excel sheet, right, you should put it on desktop or anywhere that's easy for you to access, okay? Once you click on upload new data sets, click file, choose file, and select the data set that you have extracted, which should be the student e-learning data sets that you have extracted from the data sets, okay? I'll just pause here for a short, maybe 20 seconds for everybody to catch up for those who want to follow through, okay? So just click choose file, then upload the data set that you have unzipped from the zip file. Okay, the name of the file should be this student e-learning CSV. You should get this file after you unzip the link is at the chat. So after you have unzipped it, right, just upload it and just click OK, and that should be fine. Okay, once you click OK, you'll see the file begin to upload at the bottom left here, the status. All right, so once the file is uploaded, you'll see this little message at the bottom left, right? So upload of the data sets has completed. Okay, I just pause it for another short 5 seconds to let everybody catch up for those who are following through. Okay, great. So now we will start building our AI model, right? The first thing I mentioned earlier, to build an AI model, what do we need? We need data, right? So I have prepared data for you. And earlier, I've gone through the step to upload the data. So now we are going to import the data into this workspace. So how are we going to import the data? If you go to the left, there's this save data set icon. You just click on that and click on my data set. Okay, you should see this here, e-learning, student e-learning. Ignore the rest that I have because I'm doing other stuff as well. But you should be able to see this here, student e-learning CSV. So once you have that, right, you can either double click or just left click, drag and drop to this interface here. Okay, that's all you need to do to import the data into the workspace to begin building your AI model. So now, right, before we start building any AI model, right, the first thing that I want to do is to do some visualization to understand what is going on with the data. Right? So this is the typical step that AI engineers will do as well. So a lot of time when your boss or anyone who give you data, right, they do a data dump, right? They give you one big Excel sheet with a lot of the data. I say, no, I go and do something about it, right? So before you start doing anything, the good practice is always to understand what is going on first in the data sets. So this is what I'm going to do. So what I'm going to do is I'm going to right click on this, this button here. So right click, I hover over the data sets, right? I will see this thing called the visualize. And this is what I'm going to do. So right click over the student e-learning, hover over the data sets and click on visualize. Let me expand my screen in case it's too small. Okay, great. So visualize here. So once you click visualize, you should see this screen. That's what I'm seeing right now. So I'll just go through with you how to interpret that this screen. So if you are familiar if you are a user of Microsoft Excel, you should be familiar with this interface already. So these are exactly what you'll see in an Excel sheet if you open it up, right? So at the top here, you can see at top left, 480 rows means that there are 480 examples of data points in your data sets. And you have 17 columns, meaning 17 data variables in these data sets that is given to you. So you can drag to the right and left to look at the various data sets, right? So let's say, for example, if we are interested to know about gender, so if you left click on the gender, right, and you look at the right, so immediately they will plot out things for you. For example, unique values 2, because only you're female, right? So 2 unique values. And you also have the distribution histogram chart plot for you. So you can see male around 300, female around 175, thereabout. Okay, so this is, if you put it that way, if you put it in a different way, I think this is like Excel 2.0, where it can help you do very quick data visualizations without manually plotting all the chart. So this is on, let's say, a categorical data. But if you look at other things such as for example, grades, student marks, if you scroll all the way to the right, right, you'll see these student marks. So if I click on this, right, so this way it gets interesting, right? Student marks. So take a look at this. So if you click on a column that has a continuous values as student marks, it will show you all the descriptive statistics, right, that you're familiar with, right, the mean, median, max. So you can take a look at this, right. So okay, the distribution is the center point is around 70, so median and mean around 70, and you can see that some students perform poorly 20, and some brilliant students at 100. Standard deviation is 20, and you can look at the distribution of the student performance as well. So most of the students are perform quite well, like above 60-ish. This is most of the distribution, but also there's half of students who perform quite badly, right? Like around less than 50 or so. So by one glance, you know that what are the data distributions, right? Okay, so this is to let you know how do you visualize the data. Right? So I'd like to bring your attention back to the data sets here. Take a look at this. In the data sets, you have this thing called column 0, which is nothing but an index, like an index of the data or the students, right? So this is not essential in building a machine learning model, because I mean the machine learning doesn't know what is the index of the students, right? Same for the student ID. The machine learning doesn't need to know what is the student ID of the particular students, right? And when you build a model, it's very important to know what are the models that you should remove. For example, if you keep the student index in this column, right? Let's say for some reasons, right, coincidentally, those students with lower index tends to perform better. If you keep this in your data sets and you build an AI model with this, right? So the next time when you do AI model predictions on students' results, the AI model might learn that as long as a student has a low index value, which doesn't represent anything, right? If the student has a low index value, they'll have good score, right? And that would be a wrong assumptions that the AI model learned to pick up, right? So that's why it's very important in the data stage, right, to understand what are the data in the data sets, to remove things that are not needed, and things like, for example, index, all this should be removed, and student ID usually. So you want to look at the pure students, like attributes to determine their score. So you can look at this, right? So I think this data is on e-learning, right? So you can see things like, so it's a subject. So there is, let's say, for example, semester, and raise hands, right? How active the student is during class participation, how many resources that the student visited, and announcement view. So all this relates to like how active the student is. So that's why these features or information are more important compared to the rest, right? And one last thing is here. Take a look at this. Class and student marks. So if you notice, these two are very correlated. Okay, student marks is basically continuous value, right? What's the marks of the students, right? We have a class, which, let's say, for example, low, medium, high, meaning what is the performance of the students, right? If you put it another way, it's like a first, second, third class honors. for instance, right? So if you look at these two are exactly the same. They correlate very closely. So we should remove one of them, because if you don't drop the class, right, when you train an AI model, right, they are cheating because they know what's the class already. Then it's very easy for AI model to predict the score. So if we are going to train an AI model to predict the student marks, this will be a regression AI model, right? Still remember, under supervised learning, we have regression and classifications. So for student marks, it's regressions, right? Try to predict the marks of the students. If I want to predict class, that would be the classifications, right? What is the grade of the students, right? Is it A, B, or C, high, medium, or low? So in our case, we're going to do regression values. So what we're going to do is that in the next step, we are going to drop the class. We are going to drop the column 0 and student ID. All right, so we're going to drop 3 columns from data sets. So how are we going to drop this in data sets, right? In a typical Excel sheet, you will go back, click, and delete, right? And that's usually how you do it. But let's say in Azure, what we can do is that we will manually drop out the columns that we don't want. So go to the top left, right, the search box, and you can search for things such as a select column data set. So select column, just type in select columns, and it should come up with this filtered list for you. So what we're going to do is that we're going to select column in data sets. So again, right, you can double click or left click, drag and drop. Okay, and once done, you will need to left click, drag and drop to connect the two nodes together. So you can see at the bottom of this student e-learning CSV, there's this little orange, little white circle at the middle, right? So just left click, drag and drop, and connect these two together. All right. So you should see this here. Two nodes. This little thing link up these two icons together. Okay. Once done, if I select this, left click, and when you look at the right hand side, there will be this thing called launch column selector. So just click on launch column selector. Okay, so this is where we will be instructing the tool to drop the 3 columns that we have identified earlier. So what we are going to do is that we're going to select with rules, begins with all columns, meaning that we want to select all columns right at the start. But we are going to exclude 3 things. We are going to exclude student ID, column 0, and the class. So these are the 3 things they want to exclude. So again, we begin with all rules because we want to select everything, but then we manually exclude the 3 columns that you don't want. All right, great. Again, don't worry if you can't follow. Pay more attention to the concepts. Right? This is more important. All right, great. So once that's done, right, we have removed the 3 columns that you don't want already. Okay, now I bring attention back to the data sets again, right? So if you look at data sets, right, so you look at the data that you have, right, they are very interesting in category of information here. So for example, things like stage ID, like which stage of their the student are they is it a primary school or secondary school? Are they mom or dad? Are they first semester, second semester, right? And the subject. So all these information are what we call categorical informations, or informations that belongs to a category. Things like weather, is it rainy, sunny? Things like gender, male, female. Things like seasons, like winter, summer, spring, autumn. All this belongs to category, and we need to tell the AI that these columns are categorical columns. And the reason why is because there is a special way of processing this information during the machine learning stage for categorical information. I won't go into the details, the math part, but in short, we need to tell the machine which columns are categorical to make the machine learn better and for the AI model to work. Because otherwise, they might throw out a few errors here and there. Okay, so this is what we're going to do next. So we are going to put in a new icon. We are going to search for edit metadata. So it's search for edit metadata. So once you search for this, right, it should come at the top here. Okay, so just drag and drop again and connect these two. Right. So once connected, right, you can see this, you'll see this exclamation mark here, value added. It's because we have not selected anything yet. So again, at this stage, we are going to tell the AI what is categorical information and what is not categorical information. Right. So the way we do this is that we left click here, okay, and you will see this launch column selector again, okay. So you're just going to click on that to select the columns that we are going to. So you're going to select the categorical information, right? So that AI knows. So again, what we're going to do is that we're going to click with rules, but this time round, we will begin with no columns, because earlier we want to select everything and drop 3, but now we want to manually select what are the categorical informations, right? So we are going to begin with no columns, and we are going to manually include some of the things that we have identified earlier. So things like gender. Gender will be a categorical information like male and female. Things like stage ID. Are they in primary school, secondary school, etc. The section. Which section are they at? Just now they are in different sections, right? Earlier we identified. The topics. Is it math, English, or science? These are all categorical information. We have semester. Is it the first semester or the second semester? These are categorical information as well. We have relation, the dad and mom. Remember earlier we saw this dad and mom thing. So perhaps this is like who is the parents guiding the students during e-learning, right? So they have this data as well. So relations, things like a parent answering survey, like is how often they're answering the survey, right? That's now there's a yes or no column, and there's a parent school satisfaction. Yeah, how satisfied are the parents with the school, right? And lastly, I think it should be this student absent days. Okay, so these are the things that we are going to exclude out. So in case you're wondering how come we are setting all this, right? So let me open up my screen in a different monitor. I just want to share with you here. Here. See, right, student absent days, right, we put as categorical because the way that the data is structured is different. You may imagine that, hey, the tempo, like student absent days, I thought it's 1, 2, or 3 days, right? Yes, you're right. If there's 1, 2, or 3 days, it's not categorical. It's like normal numerical values, right? You don't need to tell AI that it is categorical. But the way that the data is being captured is this, right? Under 7 or above 7. So now it become a category, right? If you're under 7, you're in one category. If you're above 7, is in another category, for example, right? So here, and let's say parents' school satisfaction, yeah, right? Good or bad. Again, this categorical. We have things like parents answering survey question, yes or no. So again, these are all categorical, right? And these are relation semester. These are all the columns that we have selected here to tell the AI that these are all categorical information. Great. Okay, so now I will move on. For those following, I hope you are able to catch up. Right. Otherwise, again, don't worry. There's a list of instructions at the slides for you to follow. Okay, click OK, done. All right, so let me do a quick recap here. So first, what we have done is that we have downloaded the data from somewhere, right? It could be from internal database or whatever there is. So you obtain the data, you upload to this platform. Then first we look at the data, right, to do some quick visualizations to understand what kind of data are we dealing with. And we realized that there are 3 columns that we want to remove: the ID, index, and of course the class marks, the grade of the student, high, medium, low. So we remove that in the second step. And the third step is that we are telling the AI which informations or columns are categorical in nature. So this is what we tell the AI model. So after selecting the columns on which are categorical, we have this thing called here. Look at here, right? What's inside this? There's this thing called categorical, right? And we're just going to click make categorical. As simple as that. Right? So this will tell the AI that all these columns you selected, they're all categorical columns. All right, great. Next step, when we build our AI model, is that we're going to do this thing called split data. So again, go to the top left, right? Click on split data. I manually import this in and connect these two. Okay, great. And once you select on a split data, right, go to the right hand side here, there's a 0.55, change to 0.8. Okay. All right, so this is where I will go into a bit of explanations and I will need attention. If you're still trying to follow through, pause and listen to my explanation, right? So you might be wondering, hey, Tern Poh, why are we splitting data? What is the use of this, right? And I will just give you a story to illustrate, right? So let's say, for example, if you have your students or your own kids, right, who you want to prepare for secondary school O-level exams, right? So typically, what parents do is that they give them a 10-year series, right? So 10-year series inside got 10 exam papers, right? So 10 exam papers, right? How are you going to, so out of these 10 exam papers, right? How are you going to first train the kids to learn the questions and answers, and at the same time test them their understanding after they are done learning, right? So option one is to give them the 10 papers at one go. Then they will look at the questions, then I look at the answers, then do some corrections, self-learning. Um, that will work. But the question is, right, once they are done, right, they come running to you and say, hey, Dad, Mom, I'm done with my exams preparation. Can I go and play now? Right? How certain are you that the kid did not just copy the answer, but rather the kid has understand the principles, the concepts that's being tested in the exams, right? So this is a big question mark. Right? So if you give them all the 10 exam papers to do it, then you have no other ways to test them. Right? After they're done preparing, they come to you. So option two is that out of the 10 exam papers, right, you give them 8 exam papers. Right? That's why I put 0.8 here, 80%. So you give them 80% of data sets or 8 exam papers in our case to go and figure out, go and do some like exercise and look at the answer booklets and do some self corrections. Okay, so once they are done with the 8 exam papers, same scenario. They come running into you and say, "Hey, Papa, Mama, I'm done with my exam papers. Can I go and play now?" They say, "Hey, wait a minute, no. How do I know whether you are just copying the answers or memorizing answers, right? I want to see whether you understand the concepts or not." Then the kids ask, how? I say, haha, I gotcha. So I have 2 hidden exam papers that I withhold from you right at the start, right? So the kid has seen the questions and answer for the first 8 exam papers. That last 2 exam papers are unseen. So then you'll say, haha, okay. So what we'll do is that you will finish this last 2 exam paper, which are purposely withhold from you at the start, right? It is based on that last 2 exam papers, your performance or the kid's performance, then I can gauge how well the kid has indeed mastered the concepts, right? So let's say in the first 8 exam papers, the kids did very badly. That's okay, they're just practicing everything. But let's say if the kid performed quite well in the last 2 exam papers, right, which is hidden from the kids right at the start, right? Then you can make a reasonable assumptions that, hey, like if this kid can perform quite well in the last 2 hidden exam papers, right, there's a high chance that when they go for the actual exam, the kid performance will be roughly the same. Make sense? So this is exactly what we're doing here in terms of AI modeling, right? So machines are very smart. AI is very smart. If you give them the entire data set 100%, right, they will just memorize the answer. Then they tell you that, no, I have done very well. But when you start to use them to make predictions on new data, right, then the performance is very bad. Because they could just memorize the answer without knowing how each variables relate to each other. That's why in here, what we are doing is that we are splitting data into 0.8, meaning that we are going to use 80% of data sets to train an AI model, and the last 20% of the data sets to test the model after the AI has done learning from the data. All right, I hope this clarify the question of why are we splitting the data. If you have any doubts again, just think back on how you will tutor your kids in a 10-year, the O-level preparation, 10-year series. Right? If you understand that concept, then you should be able to get this as well. All right, sounds good, great. And after you have done splitting data, right, the next thing on what we are going to do is that we are going to train the model. Right? So after we have done splitting the model, we are going to train the model. So again, you go to the top left, just type on train model. Train model. You can import this into the working space as well. Okay, so right here. Okay, so now we are going to train the model. To train the model, what do we need? Remember earlier the equations, right? AI equal to data plus algorithms. So exactly this is here. AI equal to data plus algorithms. So where's the data coming from? The data is coming from the split data, right? The 80%, 20%. So what I'm going to do is I'm going to connect the split data to the train model here, like this. Left click, drag and drop. Yeah. So that's it. We are telling the AI that we are going to use this split data, 80% of the split data, to train the AI model. That is the first note there. There are two output, right? So just take note, connect the first one to here, not the second one. Because they are splitting the data 80-20, right? So 80% used to train the model. The last 20% is used to test the model later on. This will be done later on at a later stage. All right. All right, so now it's the interesting part, right? Train model. There are so many AI algorithms. Which is the one that we're going to use? And what are the options available? So if you go to the search box again, you type regression. Because we are going to predict the student marks, right? So we are doing a regression use case, right? So you type regression, right? If you go down, here. Okay, so this way get interesting. So if you type regression search for it, right, you'll see all these like these interesting models that's popping out. Right? Look at this. We've got Bayesian linear regression, boosted tree regression, decision tree regression. So all these are regression values that you're trying to predict, right? Okay, so again, if you go back earlier, right, to the select column data sets, right, we have dropped the class, meaning that our use case is not classification, our use case is regression. We are going to predict the student marks. That's why you're going to use one of the things here. But let's say, right, at the end of today, walk through, you are curious, you want to play with this model again, right? Let's say instead of dropping the class, if you want to drop, let's say, I just give an example here, no need to follow. So let's say instead of dropping class, you go and drop the marks. Then it became, the use case became a classification use case, right? So instead of predicting a student marks, you are trying to predict the grades of students, right? The class, right? High, medium, low. Then it become a classifications, right? Make sense? So the same data sets, different use cases. So that's why in the earlier sharing earlier, I mentioned that the way you define problem statements is very important, because the way you define problem statements will change the way how the AI engineers approach it, will change the approach that people use to build an AI model. Okay, so I just close this up before saving. So we are going to do a regression at the previous student scores. Okay. So there are many regressions here, right? So I believe everybody knows these are linear regressions. So this is the classic. We're going to try linear regression first, all right, shall we? So let's try linear regression first. So just go and drag and drop linear regressions here and connect it to the tree model like this. All right. So AI equal to data plus algorithms. I have the data come in from the split data. I have the algorithm that is decided by me, which is linear regressions. So these two are done, and these two goes into the train model. Right. So now you see this little exclamation mark at the train model, right? Why is there an error? Let's take a look at this. Let's click on this. Let's hover over value required. Okay, so a lot of times if you see exclamation mark, it could be like you forget to print a value. So in our case, right, why do you think there is this error appearing? You have the algorithm, you have the data, but why is there still an error? Recall that the data set has tens of columns, right? The AI can take the values of all the other columns to predict the outcome of a single column. So let's say, for example, you got like things like the parent satisfaction, all this, right? So you need to take all this to predict one last column, so which is the grades. So here, what we need to do is that we want to tell the AI, right, what is the column that we want the AI to predict on. So that's why you go to launch column selector. Okay, just select student grades. With rules, student grades, marks. That's it, done. So here, what we want to do is that we just try and tell the AI that, okay, I want you to build an AI model to train to know how to predict the student marks. Okay, as simple as that. Okay, done. And that's it. Okay, this is the flow of the training part. And the next thing you want to do is that after you train an AI model, right, you want to evaluate the AI model, like in terms of its performance, right? How well is it doing? So what we're going to do is this. Okay? We are going to search for score model. Okay, so right here, score model. So just connect these two like this. That's it. Okay, I just pause it for a while. I let everybody catch up for those who are following. I'll just do a bit of explanation here. Okay, so let me do a quick recap here. First, we import the data. We look at the data. We saw that there are 3 columns that we don't need. At the second step, we remove that 3 columns. At the third step, what we did was we tell the AI model which are the columns are categorical in nature. Categorical meaning, again, like male, female, cat stocks, they're all categorical. So we're going to tell the AI model that which are the columns that are categorical. Once done, next we do a split data, right? Like the O-level exam preparation I mentioned earlier. How do you prepare your kids to do the exams, right? 8 papers practice, last 2 paper test. So this is exactly what is happening. See, right? First note is the 80% of the data, right? It goes to train the AI model. The last 20% of the exam paper flows directly to the score model to evaluate how well the AI model can perform on an unseen data set, which is purposely hidden from them at the start. All right, great. So after scoring the model, the last thing we want to do is to evaluate the model. So if you search for the evaluate model here, evaluate model, right here. Okay, so go ahead, put it to the last step and link them up together like this. Okay, so I'll just pause here for a short while and let everybody catch up. So this will be the complete flow of the entire exercise that we have gone through earlier. Okay, import data, drop the columns in the data sets, tell the AI which column are categorical, split the data. On the left, we use the 80% data to train using linear regression. Then on the right, the data flows down to the score model to do the predictions, to test how your model is performing. Lastly, we have this evaluate model. Okay, once you have completed all this, right, the next step is to click run at the bottom here. Just click run. Okay, so now the AI model will start to run to train itself to do the self-tuning of the AI model. All right, so just give it like 20 seconds. I should finish running. So once it's done running, you'll see a tick at each box. All right, done. Perfect. Fast and sweet. Right. Why so fast, right? Because we have a small data set and we are using a very simple algorithm. It's called linear regressions. If if we are doing this on a larger scale, where you have millions of data points, and if you're using more complex algorithms, it could take a few hours to run even, right? So the reason why it's so fast is because we're using very simple data sets and very simple algorithms, right? So don't get a wrong understanding there, no? Building AI models so simple, so fast, right? Then why is a vendor charging you so much money to build AI model? They're going to charge you 100 hours, right? You can do this in 5 minutes, right? No. So this is a very simple AI model to build. So don't get the wrong impression that no, AI engineer's job is easy. My job is not easy. All right. So this is the whole flow of it. So now I can teach you how do you evaluate the AI model, right? So if you left click on the, you right click on the score model, you hover over the score data sets, right? You see the same thing called visualize, right? So go ahead and click on this, right? So right click on score model, then left click on the visualize. Okay, let's take a look. Okay, interesting. So let's take a look here, right? So right at the start here is all the columns that are being used to build the AI model, right? Take a look. The column index, the 012 is gone, right? We drop it, right? So the first column is gone, and the student ID is gone as well. We drop it. I'd like to bring attention to the extreme right here, the extreme right. Okay, take a look at this. Student marks. So student marks is the actual marks or the correct answers that the students have performed, given all the attributes of students, right? Like are the parents satisfied with the school, do they participate in discussion, things like that, right? So this is the actual performance. Take a look at this. Scored label is what the AI predicted to be. So how do you interpret that? So first student, actual score is 92, but AI predicted 76. Not that good. Second student, actual score 49, AI predicted 49. Oh, this is pretty good. Third one, actual score is 22. AI predicted 44. Very bad. But the fourth one is quite good, no? 65 and 67. Very close, right? 1-2 marks difference, right? But it's very tedious to go through one by one to access the AI performance, right? So what is the better way to do this, right? So if you close this, you go to evaluate model, right? You right click again, go to evaluate results and visualize. Right here, you get the overall metrics to gauge the AI model performance. Okay, so take a look at this, right? So at the top left, you'll see the usual metrics, right? To measure how good the best fit line fits, right? You got mean square error, RMSE, things like that, right? So you take a look at this, right? At the bottom here, you have the error distribution chart. So a lot of small errors, I would say, like around here. There are some pretty big errors as well. So one error is around like how much? I think 30 something frequency 2. So there are 2 students marks predicted 30 something. That's wrong. And overall, I think the RMS is around 13, right? So of course, like the lower, the better. Then you might be asking, hey, like Tempo, like, come on, this AI model is performing so badly, you know, like so many errors here. I want the distribution to be more to the left, right? Skewed to the left, you know, because I want minor error. So what can I do? Right. So there are 2 ways to resolve this, right? As any like AI projects. First, collect more data. It could be, let's say, for example, in a data set, so you have math, science. Let's say there's a particular type of predictions that is underrepresented. Let's say, for example, science. There's less science rows in the data sets. Mostly are math. Right? So when you do that, then the machine might not be able to learn that well. And you might be asking, hey, Tempo, I follow your step exactly 100%. No? Why is my RMSE different from yours? Okay, the reason why is because I had a split data, right? The data is split randomly, 80-20, right? So randomly split. So our RMSE would be different, but they should not differ too much. Okay, so again, I repeat, if even follow the steps exactly, the RMSE will be different because due to some probability, randomness there by randomly pick value, right? So it won't be the same. So first thing, to improve the model performance, get more data to make sure that data is representative of what you're trying to do. What is the second thing you can do? Again, we call back the formula, right? AI equal to data plus algorithms. So it could be because I know the linear regression we use, right? Maybe it's a bit too simple, right? No, this is what secondary school kids use to solve their math problem. Right? I'm beyond that already, no? Linear regression, no? I'm too cool for that. Let's do something else that's more fanciful, and let's do that. So what you can do is that, right? You select this linear regression, just left click this, select this and left click. Okay, left click, select this and hit delete button. Delete away the linear regressions. Okay, so remove that. And same thing, you're going to go back to the top left, right? Here, search for regression. All right, here. There are other fanciful regression here. Neural network is deep learning, and you have other machine learning algorithms here. Today, I feel a bit green, so let's do a forest, shall we? So there's this thing called a decision tree forest. I think this is random forest for those who are in who are familiar with AI. But anyway, that's a joke, right? So let's do decision trees, right? Trying to be green, so let's use a forest, right? So I present to the boss, right? Boss asks you why you feel green today, right? So you import in the decision forest decision forest regression in the same manner, link it up with the train model as you have done earlier for the linear regressions. Right? So here, just connect these two. And done. All right, so there you go. Right now, let's try to experiment a new model called decision forest regressions. All right, and I will click run as well. Okay, and wait for it to done. Okay, so while this is running, I have to give a bit of commentary because remember earlier I mentioned to you that the more complex the AI model, the longer the time it take to run. Okay, so whenever you use something more complex, it will take a bit longer to run an AI model typically. Okay, so let's wait for it to run finish, and okay, you're done. Let's take a look at the last one. Okay, done. So same thing again, I'm going to evaluate the model, visualize. Let's take a look, right? So so RMSC, right? Okay, so you're asking how come the chart move, right? Just like here, now is there. This is the way, this is the way Microsoft Azure program the algorithms are, right? So this is the way you visualize, nothing to do with your settings, right? So let's take a look at this, right? So now the RMSC is like 11, right? So I can't remember earlier value. Is it 13 or so? So right now, it's a bit lower, I guess, right? Because typically when you use some more complex algorithms, the performance should increase, right? And there's one other crucial steps which I have not gone through, but and I will go through it today, right? So if you look at a typical machine learning algorithms, right? There's a very crucial steps to ensure that the AI model is performing at its best. And this is called hyperparameter tuning. Tune model hyperparameters. So this is one of the settings that the engineers will do to optimize the AI models. Because right now, what we are doing is that, right, if you left click on the decision forest regressions, right, take a look at here. So you have a number of decision trees, maximum depth, all this, right? Number of random split, all these little things here. And all these are the settings that we put into the AI model before it start to run and train, right? You may be asking, right, no, 8, why not 7 or why not 10, right? I also don't know. A lot of the times for all these like hyperparameters tuning, right, we leave it to the AI to figure out what is the best way, what is the best settings to achieve the results, right? And a lot of times we do this called the tune model hyperparameters. So this is where the engines will leave the machine to run overnight. You'll try different permutations of the settings that you see on the right hand side here to try to determine what is the optimal values for the machine learning algorithms, right? We won't be covering it here today because again, today The main purpose is not to train everyone here to become an AI engineer, but it is to give you a sense of the appreciation of what goes behind the scene in building an AI model. Okay, so typically, you may be wondering, I know 8, 10, what if I change, right? So typically, when you increase the complexity of the AI model, let's say, for example, right now, the trees is 8 trees, right? You might say, hey, let's go green, right? Why not? Why 8 trees? Let's say, let's put 20 trees, right? So typically when you tweak the AI model to become more complex, the more trees there is, right? I mean, for this specific AI model, right? The more complex it will get, and typically a more complex model would give a better performance, right? But there's a catch there. If the model is too complex, right, it will become a stage where the AI model is overfitting to the data. So when it overfits, right, and the model is too complex, then the model performance might drop as well. Okay, so it's not always the case where the more complex the model you use, the better it is. So this is very important, right? So when you are talking to vendors or any data science team doing AI model, right, it is not always the case where they say we're going to use some super duper complex model to build a model. That's the best. No, sometimes a simpler model that works equally good might be better because a simple model is easier to understand, runs faster, and has lower risk of overfitting the data. All right. So again, right, I just do a quick summary of my discussion earlier, right? Not when you use a more complex model, doesn't mean it is better. Okay, if you can achieve a similar result using a simpler model, then uh, you will be able to do it. Is much more preferred. Okay, to use a simpler model instead of much more complex model. All right. So with that, I just do a last recap, and I think we are done for the hands-on. All right. So in case anybody is lost during the whole flow, first we import the data by downloading it from somewhere. We look at the data. We identify columns that are not needed. Next, second step, we drop those columns that are not needed. So this is crucial. Otherwise, the AI algorithms will learn the wrong thing. Third, we tell the AI model what are categorical informations, right? And we turn them into a categorical informations by making a turn category. We split data into 80-20. So then 80% used to train the AI model, 20% used to test the AI model performance. Right? So this is crucial. Then right now we use the decision forest regression to train the AI model. So this is our weapons of choice for today. If you're interested, you can delete this and use other algorithms as you deem fit. Okay. Then we use the score model to test the actual performance of the AI model by using the unseen data sets. And lastly, we do an evaluation of model to evaluate the metrics of the AI model to see how well it's performing or not. So again, back to this point here, right now our model performance is terrible because of two things. First, our data might be insufficient enough to build an AI model. If you look at it again, our data sets, it's only a few hundreds of columns, right? This is insufficient, typical to build a model. 480 is too low, right? This is not good example, but this is too low, okay? Insufficient data sets. Secondly, the algorithms might not, you need to tweak the algorithm to tune it, like your car engines, so you need to optimize it to run its best, because otherwise we will not be able to achieve the optimal performance out of the AI model. So again, data sets and algorithm, these two will affect the end result of the AI model, right? And with that, thanks for your attention for this hands-on session. I'll stay behind for the questions.